Okay. So refraction through a glass slab. Just imagine this is a glass slab. A ray of light which comes from here. This is called as incident ray. So here we have a ray called as normal ray, which we take it as straight. So when it passes, it forms an angle and bends. Did you see here it bent? It has to actually move here straight like this, but it has bent. But now this was rarer medium, it is denser medium. This is thicker. Air is rarer medium. Alright? Because the velocity of light in air is air is not so thick. Actually, it is the velocity of light in vacuum. Vacuum dagide. Vacuum andre where there is nothing, no air, nothing. The vacuum is present between sun and earth. That is called vacuum. So in air also very negligibly less. The velocity reduces, but negligibly less. Whereas in the glass, in the water, in the oil, in any other matter, if you see, the density is more. So this is called as denser medium. The air is called as rarer medium. So the light is traveling from rarer to denser. It bent. Now again what happens? Again it is passing from denser to rarer medium. Again it is coming to the outside. Can you see how many times it bent? How many times did the light bend?
Two times.
Two times. When it was going from rarer to denser, it bent. From denser to rarer also, it bent. So you can see refraction happened two times. As a result, if it is thicker and thicker glass, ಎಷ್ಟು ದಪ್ಪನ ಗ್ಲಾಸ್ ತಗೋತಿರಲ್ಲ ಅಷ್ಟು ರಿಫ್ರಾಕ್ಷನ್ ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ಎಷ್ಟು ರಿಫ್ರಾಕ್ಷನ್ ಜಾಸ್ತಿ ಆಗುತ್ತೆ, ಬೆಂಡಿಂಗ್ ಅಷ್ಟೇ ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ಎಷ್ಟು ಬೆಂಡಿಂಗ್ ಜಾಸ್ತಿ ಆಗುತ್ತೆ, the words you will see bigger and bigger or different in shape change. So you can experience this if you take water in your pen ಒಳಗಡೆ ನೀರ್ ಹಾಕಿದ್ರಿ ಅದರೊಳಗಡೆ refill ಹಾಕ್ರಿ, the refill looks bigger. So if you take the same refill and dip in a big jar of water ಅದರೊಳಗಡೆ ಹಾಕ್ರಿ ಅದಕ್ಕಿಂತ ದಪ್ಪ ಕಾಣಿಸುತ್ತೆ. Because as the water becomes denser and denser, the refraction is maximum. I hope you understood what is happening here in this diagram. So this is an experiment of the glass slab. Example ಕೇಳಬಹುದು, show the refraction. Draw a diagram to show the refraction in the glass slab ಅಂತ ಕೇಳಿ. So this is the refraction number 1, refraction number 2. So twice the refraction is happening, and this is the actually the path of light. ಹಿಂಗೆ straight ಹೋಗಬೇಕಿತ್ತು, ಆದರೆ ಅದೇನು ಮಾಡ್ತು, ಬೆಂಡ್ ಆಯಿತು. As you can see, these two will be parallel to each other. ಎರಡು parallel ಬರ್ತವೆ. So this is the normal ray, angles. Angle of incident ray ಮತ್ತೆ normal ಗೆ ಒಂದು angle ಆಯಿತು. Incident refracted ray and normal we got the angle. Here also got the angle. With this we have the laws of refraction. Do you know the laws of refraction? Atrange ಇದೆ ಇದು, similar. What are the three rays here? Incident ray.
Normal
What
ray.
is this ray? Refracted ray
Refracted ray, normal ray.
and normal ray. At the point of intersection where they are meeting here, at this point, all of these will lie on the same plane. In the same plane. ಅಂದ್ರೆ ಈ ಕಡೆಯಿಂದ ಹೊಂಟಿದ್ರೆ ಇಲ್ಲೇ ಸ್ವಲ್ಪ ಬೆಂಡ್ ಆಗಿ ಆ ಕಡೆ ಈ ಕಡೆ ಹೋಗುತ್ತೆ, ಆದ್ರೆ ಕೆಳಗೆ ಮೇಲೆ ಹೋಗಲ್ಲ. ಸೇಮ್ ಪ್ಲೇನ್ ಅಲ್ಲಿ ಬಟ್ ಇನ್ ಎ ಸೇಮ್ ಪ್ಲೇನ್. ಲೆಂತ್ ಬ್ರೆಡ್ತ್ ಅಷ್ಟೇ ಚೇಂಜ್ ಆಗ್ಬೋದು, ಹೈಟ್ ಬರುವುದಿಲ್ಲ. Are you getting? So this is the first law. Second law is very simple. As you can see, this is angle of incidence. R is called as angle of refraction. Reflection alla refraction, and both the angles are not equal to each other. There is a ratio. Sin I by sin R is always constant. So this is the law number 2. Remember this. What is the law? The ratio of the sine of angle of incidence to the sine of angle of refraction is always constant, where I is always greater than 0 and it is always less than 90 degree. 0 degree, 90 degree. So these are the two very important laws. For 2 marks, they may ask this law, law of refraction. Take it down now. Just a minute, I will be back. Did you write?
Yes, sir.
May I repeat now? ಎಲ್ಲರೂ ಬಂದ್ರೆ ಇಲ್ಲೋ ಏನ್ ಮಾಡತ್ತೀರಿ ಎಲ್ಲರೂ? Okay, next let us understand what is refractive index. So in the same glass slab, so as you can see, this is rarer, denser and rarer. In the first example, in the first refraction, you can see it is between the rarer medium and denser medium. So we can call it as N21. So you can call this as number 1, number 2, and this is again the number 1. So the refractive index 21, which is taken as the speed of light in air divided by the speed of light in glass slab. This is for the first ratio. The second ratio, when it is coming out of the glass slab, hence 1, 2, which is taken as speed of light in glass slab divided by, ಹೇಳ್ರಿ,
speed of light in air.
Speed of light in air. So in general, if you want to see, this is nothing but the ratio of speed of light. So if there is a ratio difference in the speed of light, suppose ಈಗ speed of air ದಾಗ 3 into 10 to the power 8, glass ಒಳಗಡೆ ಇದು 2 into 10 to the power 8 ಆಯ್ತು ಅಂತ ಇಟ್ಕೊಳ್ಳಿ. Then what happens? You will cancel these two. 3 by 2, you will get 1.5. This is of glass slab. This is the refractive index of the glass slab. Refractive index of the glass slab, and always remember the refractive index will be always greater than 1. 1 ಗಿಂತ ಜಾಸ್ತಿನೇ ಇರುತ್ತೆ. ಯಾಕೆ ಹೇಳ್ರಿ? Because speed of light in the air must be greater than, always it will be greater than speed of light in any other medium. ನೀರೊಳಗಿರಲಿ, ಆಯಿಲ್ ಒಳಗಿರಲಿ, ಯಾವುದೇ ಒಂದು ಗ್ಲಾಸ್ ಇರಲಿ, it will be always greater. So now let us define properly the refractive index of any two objects. Means if I compare, that is nothing but speed of light in air divided by the speed of light in objects or other medium. So this is important. If you are asked the question, define refractive index, you should write this. Refractive index is the ratio. What it is? Divided by brother ratio. La? It is the ratio of speed of
Light in air.
Light
Light
in
in air.
air. Light in air.
to the speed of light in
Speed of light in
object.
objects.
Object in other media.
Object or
Objects or in the other medium. This is called refractive
medium.
index. And the textbook they have given, ಯಾಕಂದ್ರೆ ಈ table ಓದಬೇಕಾಗುತ್ತೆ ನಾನು. I have to read this table because there were questions given on this table. See, I will read it. We can also see here. So you can see there is a table given in your textbook. The refractive index of air is 1.0003. Refractive index of ice water is 1.31. Alcohol, ice is 1.31, water is 1.33, alcohol is 1.36, kerosene 1.44, fused quartz is 1.46, turpentine oil 1.47, benzene 1.50, crown glass 1.52. As I had told you, always it will be greater than 1. Refractive index will be greater than 1. ಯಾಕೆ ಹೇಳ್ರಿ? Numerator is always greater than denominator. ಯಾವಾಗಲೂ ಯಾಕಂದ್ರೆ speed of light in air will be always 3 into 10 to the power 8 meters per second. Next, Canada, what is this? Balsam, Canada balsam. This is also a type of, one type sugar type, salt type, 1.53, rock salt 1.54, carbon disulfide 1.63, dense flint glass. The colored glasses ಸಿಗ್ತಾವಲ್ಲ ನಮಗೆ 1.65, ruby ಅಂದ್ರೆ ಗೊತ್ತಲ್ಲ, that is also a stone, gemstone 1.71, sapphire 1.77, diamond is 2.42. So in the last examination they had asked a question. ಏನು question ಇತ್ತಂದ್ರೆ the refractive index of diamond is 2.42. What is the meaning of that? Refractive index of diamond is 2.42. ಇದರ ಬದಲಿ ಅವರು ಏನು ಕೇಳಬಹುದು? The refractive index of a crown glass is 1.52. What do you mean by this? ಇದರ meaning ಏನು ಅಂತ ಕೇಳ್ತಾರೆ. The meaning of this is nothing but ಇಲ್ಲಿ substitute ಮಾಡಿಬಿಡ್ರಿ 2.42. The refractive index of diamond 2.42 means the speed of light in air is to the speed of light in diamond. The ratio of the speed of light in air and the ratio of the and the speed of light in diamond is 2.42. ಅಂದ್ರೆ ಇದನ್ನ ಇಲ್ಲಿ ಡೈಮಂಡ್ ಹಾಕಿ ಡಿವೈಡ್ ಮಾಡಿದ್ರೆ ಡೈಮಂಡ್ ಒಳಗಡೆ ಎಷ್ಟು ಸ್ಪೀಡ್ ಇರ್ತಿತ್ತಲ್ಲ ಲೈಟ್ ಇನ್, what is the speed of light here? If you substitute here and divide it, you will get 2.42 as the answer. Crown glass also the same thing. Again I will repeat this. The refractive index of crown glass is 1.52. What do you mean by this? The answer will be the refractive index of crown glass is 1.52 means the ratio of speed of light in air is to the speed of light in crown glass is 1.52. Did you understand? You have to divide ಮಾಡಿದಾಗ ಇಷ್ಟು ಆನ್ಸರ್ 3 into 10 to the power 8 divided by ಕ್ರೌನ್ ಗ್ಲಾಸ್ ನಾಗ ಎಷ್ಟು ಹೋಗುತ್ತಲ್ಲ ಆ ಸ್ಪೀಡ್ ಹಾಕಿದರೆ ಯಾವಾಗ ಡಿವೈಡ್ ಮಾಡ್ತೀವಿ ಅವಾಗ ಈ ವ್ಯಾಲ್ಯೂ ಬರುತ್ತೆ. Then we tell that this is the refractive index of it. And I hope you understood what is the meaning of refractive index now.
Yes, sir.
Any doubts? Hello. The speed of light is high in rarer medium or denser medium. Speed of light ಎದ್ರೊಳಗೆ ಜಾಸ್ತಿ ಇರುತ್ತೋ, ರೇರರ್ ಮೀಡಿಯಂ ದಾಗ ಜಾಸ್ತಿ ಇರುತ್ತೋ, ಡೆನ್ಸರ್ ಮೀಡಿಯಂ?
Rare.
medium.
There
Rarer medium, the speed of light is always high. than in the denser medium. Denser medium ದಾಗೆ ಸ್ಪೀಡ್ ಸ್ವಲ್ಪ ಕಡಿಮೆ ಲೈಟ್. ಸೊ ಅದೇನು ಕಡಿಮೆ ಆಗುತ್ತಲ್ಲ ಅಲ್ಲೇ ಲೈಟ್ ಸ್ವಲ್ಪ ಬೆಂಡ್ ಆಗುತ್ತೆ. ಸೊ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಇಫ್ ಯು ಟೇಕ್ ಇಟ್ ಬಾಲ್, ಒಂದು ಬಾಲ್ ತೊಗೊಂಡು ಹೋಗಿರ್ತೀರಿ, ಯಾವಾಗ ಸ್ಪೀಡ್ ಕಡಿಮೆ ಆಗುತ್ತೆ ಬೆಂಡ್ ಆಗುತ್ತೆ ಅದನ್ನ ಲೈನ್. ಸ್ಪೀಡ್ ಇರೋ ತನಕ ಸ್ಟ್ರೇಟ್ ಹೋಗುತ್ತೆ ಬಾಲ್. ಸ್ಪೀಡ್ ಯಾವಾಗ ಕಡಿಮೆ ಆಗುತ್ತೆ ಆಟೋಮೆಟಿಕಲಿ ಇಟ್ ಬೆಂಡ್ಸ್. ಸಿಮಿಲರ್ಲಿ ದ ಲೈಟ್ ಬೆಂಡ್ಸ್. ಬಟ್ ಅಲ್ಲಿ ಬಾಲ್ ಇನ್ ರೀಸನ್ ಏನು, ಗ್ರಾವಿಟಿ ಇತ್ತು, ಜಗ್ಗಿತ್ತು, ದಟ್ ಇಸ್ ಸೆಕೆಂಡರಿ. ಹಿಯರ್ there is no gravity. Gravity will not act on light. Light ಮೇಲೆ gravity ಯಾವುದೇ ತರದ ಆಕ್ಷನ್ ಇಲ್ಲ. Because light, yesterday as I explained, it is in the form of particles which travels in the form of waves. Okay, those particles will not have lot of mass. Mass ಇರೋದಿಲ್ಲ. Mass ಇದ್ರೆ gravity ಆಗ್ತದೆ. Without mass, gravity will not act on it. All right, then let's move to the spherical lenses. I hope all of you know what are spherical lenses. What is a lens? Question comes. What is a lens? Anybody knows the answer? What is a lens? Lens. Lens is a piece of transparent material. Mirror is opaque material. ಕೇಳಿದಿರಲ್ಲ ಇವು ಮೂರು? Have you heard of these three words? Transparent, opaque, then
translucent.
Translucent ಅಂದ್ರೆ transparent means which will allow the light to pass through. Light ಯಾವ್ದು ಪಾಸ್ ಆಗೋದು ಬಿಡುತ್ತಲ್ಲ, which will allow the light to pass through are called as transparent. For example, glasses ನೋಡ್ರಿ, ಇದು ಟ್ರಾನ್ಸ್ಪರೆಂಟ್ ಇದೆ, ಅದಕ್ಕೆ ಲೈಟ್ ಬರುತ್ತೆ ಒಳಗಡೆ, ಅದು ಬರಬಾರ್ದು ಅಂತ ಕವರ್ ಹಾಕಿದ್ದೀನಿ. ಕವರ್ ಹಾಕಿದ್ದೀನಿ ಅಂದ್ರೆ ಇಟ್ ಈಸ್ ಬ್ಲಾಕಿಂಗ್, some part of it is blocking. ನೋಡ್ರಿ ಬಾಡಿ, the wall is 100% blocking the light, it is opaque, which will not allow the light to pass through. ನೋಡ್ರಿ, you can see these curtains I have put here. ಒಂದು curtain ಹಾಕಿದ್ದೀನಿ, small amount of light it is allowing, partially, so they are called as translucent. Translucent ಅಂದ್ರೆ partially they allow the light to pass through. Any doubts in these three?
No, sir.
No, sir.
So the mirror what you studied was opaque. ಕನ್ನಡಿ opaque ಅಲ್ಲ, ಲೈಟ್ ದಾಟಿ ಆ ಕಡೆ ಹೋಗುದಿಲ್ಲ. ಕನ್ನಡಿ ಒಳಗಡೆ ಲೈಟ್ ಈ ಕಡೆನೇ ಹೊಡೆದು ಈ ಕಡೆನೇ ಬರುತ್ತೆ. It will not allow the light to pass through. Whereas the glasses, the lens is a piece of transparent material which is at least one side curved. So what is lens? Lens is a piece of transparent material which is at least one side curved. One side ಆದ್ರೂ curved. That is called a lens. I hope you understood. So here we will learn about the spherical lens. So we have two types, main types of spherical lens. What are those? First ಯಾವುದು?
Concave.
So this is
Convex.
What is this is convex and this is concave. Where the reflecting surface, idu reflecting surface is bulged out. Convex. Here the reflecting surface is bulged in. Mirror nagu hinge agittalla, the refracting surface, reflecting alla, refracting surface, alli reflecting surface bulged out, bulged in antidhi. Similarly here also, but remember these are transparent, whereas mirror was opaque. So take, these are the two types of lenses. Barkodri una spherical lens anteli, convex lens which is bulged out, concave which is bulged in. Okay, then when we see the ray diagrams, simple ray diagram ತೋರಿಸ್ತೀನಿ. So all these will meet at a point. All these will meet at a point. Here, so this convex length is called as, what it is called as?
Converging lines.
Converging lens.
What about this? ಇದಕ್ಕೆ ಏನಂತೀವಿ ಈಗ?
Diverging lines.
Diverging lens.
Diverging lens.
Converging lens, diverging lens. ಇದ್ರ ಜೊತೆ ಆಟ ಆಡಿರ್ಬೇಕಲ್ಲ ನೀವು, ಮ್ಯಾಗ್ನಿಫೈಯಿಂಗ್ ಗ್ಲಾಸ್ ಬಿಸಿಲಿಗೆ ಹಿಂಗೆ ಹಿಡಿದು ಬೆಂಕಿ ಹಚ್ಚಿ.
Yes, sir.
Yes, sir.
Because all
Yes,
the
sir.
rays which comes from the sun are converged and they will meet at a point. One point ಗೆ meet ಆಗೋ ತರ converge ಮಾಡುತ್ತೆ. Then automatically heat generate ಆಗಿ paper burn ಆಗುತ್ತೆ. Here they will not meet. They move away from each other. They diverge out. So these are the two lenses. Those are spherical lenses. Let us understand. Even they have got their own ray diagrams, just like how we had for the mirrors. Mirror ಹೆಂಗ್ ray diagram ಇತ್ತು, ಹಂಗೆ ray diagram ಇದೆ. To understand ray diagram, ಅಲ್ಲಿ 4 type rays ಕಲ್ತಿದ್ವಿ, ನೆನಪಿದೆ? Before parallel, after parallel, passing through C, C ದಾಗ ಪಾಸ್ ಆಗಿ ಮತ್ತೆ C ದಾಗೆ ದಾಟ್ ಹೋಗಿತ್ತು ಒಂದು. Another one, pole of the mirror ಮಾಡಿ ಕರೆಕ್ಟ್ ಆಗಿ equal angle ಇಂದ ಕೆಳಗೆ ಬಂತು. These were the 4 types of rays. So here when we draw the ray diagrams, here also we study different types of ray. Not ray number 1. How these are before refraction?
Parallel.
Parallel.
So we tell that they are parallel before refraction. This is for convex, this is for concave. So afterwards, what happens? Afterwards, so before refraction, parallel rays. These are one type of rays. Second ray. F2, 1, 2F1. So it is passing through the principal focus and it travels parallel to the principal axis. Same alle henge illu principal axis barutte. Similarly it is F1, 2F1 passes and it moves in the straight line. Diverges. ಉಲ್ಟಾನು ತಗೋಬಹುದು, ಕೆಳಗಿಂದ ಮ್ಯಾಲ್ ಮಾಡಬಹುದು. So third is a vertical type of ray. So here when you study about the lenses, the special term ಅಲ್ಲಿ pole of the mirror ಅಂದಿದ್ದು ನೆನಪಿದೆ? Do you remember pole of mirror?
Yes, sir.
Yes, sir.
Yes, sir.
Here we have optic center. ಇದಕ್ಕೆ ಏನಂತೀವಿ ನಾವಿಲ್ಲಿ? Optic center. Optic center. Any measurement you want to do, you have to do with optic center. Any measurement, object distance, image distance, any measurement idru, you have to start from the optic center. Look at this ray. This ray is passing through optic center. It is not getting deviated. Deviation will not. It passes straight away from the optic center. Got it? Understood? These are the 3 different rays which we use to draw the ray diagram. Ray diagram ತೆಗೆಯಕ್ಕೆ ಇವು 3 ಯಾವುದಾದ್ರು 2 ray ಯೂಸ್ ಮಾಡ್ತೀವಿ. Because where the rays meet, image is formed there. ಅದು important point. 2 rays ಇದ್ದಾಗ meet ಆಗಕ್ಕೆ ಚಾನ್ಸ್ ಇದೆ. So minimum of 2 rays you should draw, and those rays you should always mention the arrow mark. ಎಲ್ಲ diagram ಗೆ arrow ಹಾಕತ್ತೀನಿಲ್ಲ ನಾನು.
Yes,
Yes, sir.
Yes.
Arrows are very important to draw the diagrams. So these are the 3 different rays. So let us draw the ray diagrams. Just similar to that. Illu hengide andre I'll show you. Here instead of taking center of ಕರ್ವೇಚರ್ ಅದೆಲ್ಲ ತಗೊಳ್ಳಲ್ಲ, ನಾವೇನ್ ತಗೋತೀವಿ ನೋಡಿ. ಹೌ ಟು ಡ್ರಾ ಅ ಲೆನ್ಸ್. ಡ್ರಾಯಿಂಗ್ ಎ ಲೆನ್ಸ್ ಇಸ್ ಆಲ್ಸೋ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ಹೆಂಗ್ ಲೆನ್ಸ್ ತೆಗಿತೀರಿ? ಫಸ್ಟ್ ಯು ಶುಡ್ ಮೆಜರ್ a radius with your compass. ಕಂಪಾಸ್ ಇಂದ ಒಂದು ಮೆಜರ್ಮೆಂಟ್ ತಗೊಂಡು ಒಂದು ಸರ್ಕಲ್ ತೆಗಿ. ದೆನ್ ಫ್ರಮ್ ದಿಸ್ ಅದ್ರ ರೇಡಿಯಸ್ ಎಷ್ಟಿರುತ್ತಲ್ಲ ಸ್ವಲ್ಪ ಡಿಸ್ಟೆನ್ಸ್ ಬಿಟ್ಟು ಇಲ್ಲಿ ಯು ಹ್ಯಾವ್ ಟು ಡ್ರಾ ದ ಸರ್ಕಲ್ ವಿತ್ ದ ಸೇಮ್ ರೇಡಿಯಸ್ ಫ್ರಮ್ ಸರ್ಟನ್ ಡಿಸ್ಟೆನ್ಸ್ ಅವೇ. ಇಷ್ಟಿಂದ ಅಂತ ತಿಳ್ಕೊಳ್ಳಿ. ಸೊ ನಾವು ಹಿಯರ್ ಯು ಹ್ಯಾವ್ ಗಾಟ್, ಹಿಂಗೆ ರಬ್ ಮಾಡಿಬಿಟ್ನಿ ಅಂದ್ರೆ ವಾಟ್ ಇಸ್ ದಿಸ್?
Convex mirror.
Convex mirror.
ಮಿರರ್ ಇದು
Lens.
ಲೆನ್ಸ್. ಸೊ ಇಲ್ಲೇನ್ ಸೆಂಟರ್ ಸಿಕ್ತಲ್ಲ, ಇದಕ್ಕೆ ಏನ್ ಮಾಡ್ಬೇಕು ನಾವು? 2f ಅನ್ಬೇಕು. ರೇಡಿಯಸ್ ಆಫ್ ಕರ್ವೇಚರ್ ಅಂದಿದ್ದಲ್ಲ, ದ ರೇಡಿಯಸ್ ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ ಬರ್ತಿತ್ತು, ಇದು ಆಪ್ಟಿಕ್ ಸೆಂಟರ್. ಇಲ್ಲಿಂದ ಮೆಜರ್ ಮಾಡ್ತೀವಿ. ಸೊ ಸ್ಲೈಟ್ಲಿ ಅವೇ ಫ್ರಮ್ ಇಟ್ ಯು ವಿಲ್ ಹ್ಯಾವ್ ದ 2f, ಸ್ಲೈಟ್ಲಿ ಅವೇ ಫ್ರಮ್ ದಿಸ್ ಯು ವಿಲ್ ಹ್ಯಾವ್ 2f. So ಇಲ್ಲಿ f1 f2. Then can you tell me what is this f? See the f1 f2. f ಅಂದ್ರೆ ಏನು? What is this f?
Focus.
Principal focus.
Principal focus.
So O to f1. Can you tell me what is this distance called as? O ದಿಂದ f1.
Focal length.
Focal, just like mirror. ಇದಕ್ಕಿಂತ ಡಬಲ್ 2 into f1 ಇರುತ್ತೆ ಅಷ್ಟೇ. ಇದಕ್ಕಿಂತ ಡಬಲ್ 2 into f1. So this is how you should draw. Similarly, ಕಾನ್ಕೇವ್ ತೆಗಿಬೇಕಂದ್ರೆ ಹೆಂಗ್ ಮಾಡಬೇಕು? ಇಲ್ಲಿ ಒಂದು ಸರ್ಕಲ್, ಇಲ್ಲಿ ಒಂದು ಸರ್ಕಲ್, ಇವೆರಡೂ ಜಾಯಿನ್ ಮಾಡಿಬಿಟ್ರಿ ಅಂದ್ರೆ so this is 2f1, 2f2, in middle f2, in middle f1. If you erase the remaining part, you'll have a lens. This is how to draw the neat diagram. Neat diagram ತೆಗಿಬೇಕಂದ್ರೆ ಇಷ್ಟು ಫಾಲೋ ಮಾಡಬೇಕು to draw the diagrams. Understood? So these are the different parts. ಹೇಳ್ರಿ ಯಾವ part ಇದಾವೆ ಇಲ್ಲಿ? So this imaginary line, whatever I have drawn is called as
Principal axis.
principal axis. O andre, what is O?
Optic center.
Optic center.
F1, F2,
Principal focus.
Principal focus.
2f1, 2f2.
Focal length.
F1, F2 ನ focal length ಅಂದಿದ್ರಲ್ಲ. Distance between F1 and O is focal length. 2f2 ಕೇಳತ್ತೀನಿ, 2f1, 2f2 ಕೇಳತ್ತೀನಿ. They are the double of focal length. O ದಿಂದ 2f1 ಅಂದ್ರೆ ಡಬಲ್ ನೋಡ್ರಿ, 2 into ಇದೆಲ್ಲ ಆಲ್ರೆಡಿ ಇಟ್ ಇಸ್ 2 into f1, 2 into f2. Clear? Shall we draw the diagrams? Ray diagrams. ಎಲ್ಲೆಲ್ಲಿ ಬರ್ತಾವೆ ಈಗ objects ಹೇಳ್ರಿ. Let's have the table now. Here also you should write whether they are real, they are virtual, they are erect, they are inverted, they are magnified, highly magnified, diminished. ಇವೆಲ್ಲ ಬರ್ತವೆ. Now the object, image and their properties. ನಾನು ಎಲ್ಲ ತೆಗೆಯೋದಿಲ್ಲ ಇವತ್ತು. You have to draw few. I'll explain the others in the next class. Okay? Just I'll explain this. ಅಲ್ಲಿ ಫಸ್ಟ್ ಯಾವ್ದಿತ್ತು? ಮಿರರ್ ಡೈಗ್. What was the first one?
At infinity.
At infinity. ಹೇಳ್ರಿ, ಇಮೇಜ್ ಎಲ್ಲಿ ಫಾರ್ಮ್ ಆಗಿತ್ತಲ್ಲಿ?
At f.
At f.
ಇಲ್ಲಿ ಎಲ್ಲಿ ಫಾರ್ಮ್ ಆಗ್ತೈತಿ? ಇಲ್ಲಿ at f2 ಫಾರ್ಮ್. ನೋಡ್ರಿ ತೋರಿಸ್ತೀನಿ. ಸೊ ಹಿಂಗ್ ನಾರ್ಮಲ್ ಆಗಿ ತೆಗಿಬೇಕಾದ್ರೆ ಜಸ್ಟ್ ಮಾರ್ಕ್ 2 ಪಾಯಿಂಟ್ಸ್ ಇಕ್ವಿ ಡಿಸ್ಟೆಂಟ್ ಫ್ರಮ್ ದೀಸ್ ಟು. ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ ಜಾಯಿನ್, ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ ಜಾಯಿನ್. ನೀಟ್ ಕಾಣ್ತೈತೆ ಸ್ವಲ್ಪ. ಈ ಲೈನ್ ಆಗಿಬಿಡ್ತೈತಿ, ಹಿಂಗ್ ಲೈನ್ ತೆಗಿತೀವಿ, ಹಿಂಗ್ ಲೆನ್ಸ್ ಆಗಿಬಿಡ್ತೈತಿ. ಡಸ್ ಇಟ್ ಲುಕ್ ಗುಡ್?
No, sir.
ಇಲ್ಲಿ ತತ್ತಿ ಹಾಕಕ್ ಹೋಗ್ಬಿಡ್ರಿ. ಡಯಾಗ್ರಾಮ್. ಓಕೆ, ಇದು ಮಾರ್ಕ್ ಮಾಡಿ, ಓ ಮಾರ್ಕ್ ಮಾಡಬೇಕು ಆಪ್ಟಿಕ್ ಸೆಂಟರ್. ಇಲ್ಲಿಂದ ಒಂದು F2, ಇದು F1. ಇಲ್ಲಿಂದ ಕರೆಕ್ಟ್ ಡಬಲ್ ತಗೊಂಡು 2F1, ನೆಕ್ಸ್ಟ್ ಡಬಲ್ ತಗೊಂಡು 2F2. ಸೊ ಇವೆರಡು ಡಿಸ್ಟೆನ್ಸ್ ಸೇಮ್ ಇರಲಿ, ಇವೆರಡು ಡಿಸ್ಟೆನ್ಸ್ ಸೇಮ್ ಇರಲಿ. ಇಷ್ಟು ತೆಗೆದ್ರೆ ನಿಮಗೆ ಅರ್ಧ ಮಾರ್ಕ್ಸ್ ಕೊಡ್ತಾರೆ ಡಯಾಗ್ರಾಮ್. ಓಕೆ, ನಾವು ದ ರೇಸ್ ಆರ್ ಕಮಿಂಗ್ ಫ್ರಮ್ ಇನ್ಫೈನೈಟ್ ಡಿಸ್ಟೆನ್ಸ್, ಇನ್ಫಿನಿಟಿಯಿಂದ ಬರ್ತಾ ಇದ್ದಾರೆ. ಸೊ ಆಪ್ಟಿಕ್ ಸೆಂಟರ್ ಇದೆಲ್ಲ ಇಲ್ಲಿಂದ ಡೈವರ್ಟ್ ಆಗ್ತದೆ. See, look at the arrow mark now. The rays, the object is at infinity. The image is formed at F2. So ಇಲ್ಲಿ ಲೆನ್ಸ್ ಅಲ್ಲಿ ಮಿರರ್ ಅಪೋಸಿಟ್ ಬರ್ತೈತಿ. ಇಲ್ಲಿ ಮಿರರ್ ನಾಗೆ ಸೇಮ್ ಸೈಡ್ ಆಬ್ಜೆಕ್ಟ್ ಇಮೇಜ್ ಇದ್ರೆ ರಿಯಲ್ ಇಮೇಜ್, ಆದ್ರೆ ಇಲ್ಲಲ್ಲ, ಟ್ರಾನ್ಸ್ಪರೆಂಟ್ ಇದೆ. ಲೈಟ್ ಪಾಸ್ ಆಗ್ಬೇಕಿಲ್ಲ. Light has to pass because it is transparent. If it has to pass, object left side, image right side ittandre it is real image. Similarly, here also we will get inverted and the size is point size. Not really good. The image is very, very small because the object is far. What was the second there? Second position.
Beyond C.
Position.
Beyond C. Beyond C.
ಇಲ್ಲಿ ಸಿ ಅಂದ್ರೆ ಏನಿದೆ? ಸಿ ಬದಲು
Optic center.
2F1. Instead of C, we have 2F1. So what happens? Let us see here now. X center O, F2, 2F2, F1, 2F1. So the image is here. The image is here. So one ray passing and passes through F2. Second ray beyond the ground. Image is formed here. So this was AB. This is A dash B dash. Image and object, are they on the same side of the lens? Are they on the same
Yes,
side
sir.
or different?
Difference.
Lens same
Different.
side, different side. Different means it has to form L form the image. Image is between
F2 and 2F2.
F2 and 2F2.
between F2 and 2F2. Look, it is real. Tell me whether it is erect or inverted.
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 Ulta ಆಗಿತ್ತು, arrow ಹಾಕಿ. So it is real, inverted. Next, look at the size. This size and this size. Diminished. Diminished. That was the second. What was third one?
At C.
At 2F1.
F2.
At F1. ಲೆಫ್ಟ್ ಸೈಡ್ ಎಲ್ಲ ಒನ್ನೇ ಬರಬೇಕು, ಆಬ್ಜೆಕ್ಟ್ ಎಲ್ಲ ಒನ್ ಅಲ್ಲೇ ಬರಬೇಕು, ಇಮೇಜ್ ಆಮೇಲೆ. ಈಗ ಸ್ಟಾರ್ಟಿಂಗ್ ಅಂತ ಎಲ್ಲ ಟೂನೇ ಬರ್ತಾವೆ. ಓಕೆ, ಹಿಯರ್ ಇಸ್ ದ ಲೆನ್ಸ್ O, F1, 2F1, F2, 2F2. So object is here at 2F. So a ray passes through this, another ray passes through O and meets it here. It is A dash, B dash, it is A, D. Okay, slightly in the direction, goes from here, meets it. Now look, where is the image formed?
2F2.
2F2. 2F2.
At 2F2. And do you think it is real image?
Yes, sir. Yes, sir.
And next, it is erect or inverted?
Inverted. Inverted.
Look at the size of both. Idurdu size nodri,
Same
idurdu
size.
size nodri.
Same size.
Same side.
Same size. ಅಲ್ಲೂ ಹಂಗೆ ಬಂದಿತ್ತಲ್ಲ. In the mirror also it was the same. When it was at C, image was also at C, and they were having same size. ಅಲ್ಲೂ ರಿಯಲ್ ಇತ್ತು, ಅಲ್ಲೂ ಇನ್ವರ್ಟೆಡ್ ಇತ್ತು, ಅಲ್ಲೂ ಸೇಮ್ ಸೈಜ್, ಬಟ್ ಇಟ್ ವಾಸ್ ಕಾನ್ಕೇವ್ ಮಿರರ್. Here it is convex lens. Is our ray diagram of the convex lens it is. So these are the three. Can you tell me what are the next 4, 5, 6? ಹೇಳ್ರಿ ನೋಡು.
Between 2F1 and F.
2F1 and F1.
So the first one was at infinity. ದೂರ ಇತ್ತು. The first one was at infinity. Next it came near, beyond 2F1. Next F1 ಮೇಲೆ ಬಂತು. Next ಎಲ್ಲಿ ಹೋಗುತ್ತೆ? Between
2F1 and F1.
2F1 and F1.
2F1 and F1. Next, after here, ಮುಂದೆ ಎಲ್ಲಿ ಹೋಗುತ್ತೆ?
At
At
F1.
F1.
At F1.
At F1. Next, last,
Between F1 and optic center.
between F1 and optic center. So yesterday also I did the same thing. You ಮೂರು ನಾನು ತೆಗೆದು ತೋರಿಸಿದ್ದೆ, ಮೂರು ನೀವು ತೆಗಿ ಅಂತ ಹೇಳಿದೆ. And today I drawn the remaining 3. Today also you practice with all these 6. Tomorrow I will explain the remaining of these the diagram. ಅದಕ್ಕಿಂತ ಮೊದಲು let us write this part at least. ಈಗ ಹೇಳ್ರಿ ಇದೆಲ್ಲಿ ಬರುತ್ತೆ? ಇಮೇಜ್ ಎಲ್ಲಿ ಫಾರ್ಮ್ ಆಗ್ತದೆ? Between 2F1 and F.
Beyond
Beyond
1.
2F1 ಯಾಕೆ? 1 ಅಂದ್ರೆ ಲೆಫ್ಟ್ ಸೈಡ್ ನೋಡ್ರಿ. ಈಗ ಇಲ್ಲಿತ್ತು, ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ ಹೋಗ್ತಿ, ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ ಇಲ್ಲಿ ಹೋಗ್ತೈತಿ. ಈಗ isn't it beyond 2F2? Next at F1. F1 ಇಗಿದ್ರೆ
At infinity.
At infinity.
Here also there is interesting pattern just like yesterday. At infinity, at F2, at F1, at infinity.
Yes, sir.
The number beyond 2F1, between F2 and 2F. Next here, between 2F1 and F1, beyond 2F2. Not revealed to link. And 2F1, 2F2. So the last one will form the virtual image as we saw even in the mirror of concave. That we will discuss in the next class. Illu discuss ಮಾಡೋಣ ಇದು. I think they will be magnified image, no? ಇವೆರಡು ದೊಡ್ಡ ದೊಡ್ಡ ಹಾಕೊಂತಾನೆ ಹೋಗ್ಬೇಕು. ಫಸ್ಟ್ ಇಷ್ಟ ಇತ್ತು, ಆಮೇಲೆ ಇಷ್ಟ ಆಯ್ತು. It becomes bigger and bigger. Then when it comes here, image is not formed on that side, image is formed on the same side. So let's discuss more about this concept in the next class. Today's work for you, you have to draw all the ray diagrams. ನಿನ್ನೆ ತರ ಮಾಡ್ಬಿಟ್ರಿ, please I request all of you ತೆಗೆದು ತೋರಿಸ್ಬೇಕು. ನಿನ್ನಿದ್ ಇವತ್ತು ತೆಗೆದು ನನಗೆ ಈಗ ಟೀಚ್ಮೆಂಟ್ ದಾಗ ಒಂದು ಅಸೈನ್ಮೆಂಟ್ ಅಂತ ಹಾಕ್ತೀನಿ. You have to submit that without fail. All of you have to submit it. Will you submit?
yes, sir.
Yes, sir.
It may be concave, it may be convex. With the laws of reflection. Laws of reflection over here plus ray diagram of okay, I'll just put it now. You have to